Let's start with problem number 1. Problem number 1 reads 3 times 4 to the third power. Well, 4 to the third power would be the same as 4 times 4 times 4. So we would essentially end up with 3 times 4 times 4 times 4. Since we've learned our cubes, we already know that 4 to the third power is 64. So we're left with 3 times 64, which equals 192. Problem number 1 was a rather simple problem. Now let's look at problem number 4. Problem number 4 reads 2x cubed times 2x squared. Now we can see that we have x's, so we have the same bases, and both of them have powers. We're going to use our product rule, where that will allow us to add the powers together. But just to help reinforce the process that's taking place, I'm going to expand this just a little bit and separate some things out, because remember that when you're multiplying values, the order can be rearranged through the commutative property. So I'm going to rewrite this as 2 times 2 times x cubed times x squared. And we know that 2 times 2 becomes 4. And through our product rule, we end up with x to the third times x squared is the same thing as x to the 3 plus 2 power. So let's clean this up one more time. 4 times x, 3 plus 2 is 5, to the 5th power. Let's look at number 7. Number 7 is 8 to the 0th power. Now we discussed in class and we proved in class how anything to the 0th power is equal to 1. So that was a really quick, really easy problem. Number 8. Number 8 is negative 9x to the 0th power. Now there's two ways to attack this problem. Our first and probably easiest way is to remember that 0th power applies to everything inside the parentheses. And so 9x to the 0th power is going to equal 1, and that negative sign being outside the parentheses will simply attach to the 1. We have a solution of negative 1. The alternative way is to remember the power on each item inside the parentheses currently. 9 has a power of 1 and x has a power of 1. Both of those, because they're inside the parentheses together, are being raised to the power of 0. So we are going to utilize our power rule, which states that we can multiply the power of each term to the power outside the parentheses. And that would look something like 9 to the first power raised to the 0th power would be 9 raised to the 1 times 0 power. And 1 times 0 is 0, so that leaves us with 9 to the 0th power. X raised to the 1 times 0 is 0, so x to the 0th power. And we could simplify both of those exponents. We would end up with 9 raised to the 0th power, which is 1, times x raised to the 0th power, which is also 1. And when we finalize this problem, we determine that 1 times 1 is 1, so our solution is negative 1. Either way, notice that we got the same solution, just two different processes for getting there. And you'll find as you work through exponents that you may have utilized one process while a peer may have utilized a completely different process, and both of you are right, so long as you get the right solution. Number 12. Number 12 reads 8x to the 5th over 4x squared. Now the first part of this problem that I'm going to deal with is the 8 over 4. 8 over 4 simplifies very cleanly. We know that 8 divided by 4 is 2, so that leaves us with a 2 in the numerator. Now the next part I'm going to deal with is my quotient rule, because I have x's that share the same base and both are being raised to a power. So our quotient rule tells us that we can keep the base and subtract the powers. So x to the 5 minus 2. Now again, we're going to clean this up a little bit, and that will leave us with 2 times x. 5 minus 2 is 3, so raised to the third power. Let's look at one that's maybe a little bit more complicated. Number 18. 5x cubed y over 20 x y to the 5th. All of that being raised to the 4th. Now I can certainly apply my power to power rule and carry that out to every term inside the parentheses, but before I do that, I'm going to simplify this fraction 5 over 12. 5 over 12, 5 over 20, 5 goes into 24 times, so that's going to leave me with the fraction 1 over 4. And I'm also going to go ahead and simplify the power to powers, the quotient rule problems with the x cubed over x. And that would give me x to the 3 minus 1. And I'm also going to go ahead and simplify my quotient rule with the y's. And that would give me y to the 1 minus 5. All of this is still inside parentheses raised to the power of 4. So let's clean this up a bit. 1/4 times x to the 3 minus 1, which would be x to the 2nd power, times y to the 1 minus 5, which would be y to the negative 4th power, all in parentheses raised to the 4th. Now we still have options, but I don't like negative power, so I'm going to clean that one up before I do anything with the parentheses still. 1 over 4 to the x squared, and my y to the negative 4th, I don't like the negative power, so I'm going to kick it downstairs into the basement, and it becomes positive. Y to the 4th power, all of that raised to the 4th power. Now we should see that we have some power to power rules. In order to make sure that I apply my powers to every term, I'm going to give my numbers or my coefficients powers as well. And we're going to apply the power to power rule. 1 raised to the 1 times 4 would be 1 to the 4th power. x raised to the 2 times 4 would be x to the 8th power over 4 raised to the 1 times 4 would be 4 to the 4th power. Y raised to the 4 times 4, which is 16. And now I see a 4 to the 4th power, so we're going to clean that up. And we will end up with 1 to the 4th power, which is 1. X to the 8th over 256. Y to the 16th power. All right, let's go for another slightly messy one. 33. 2x to the 3rd power. Y to the negative 3rd power. Raised to the negative 2nd power. Now I could certainly deal with the negative 3rd power that's attached to the y, but since I realize that I have a negative power outside the parentheses, I know that's going to impact terms inside the parentheses. So rather than moving stuff downstairs and then bringing it back upstairs, I'm going to go ahead and apply my power rule. So please remember that 2 is to the 1st power. So we're going to multiply 2 raised to the 1st times negative 2 power. Well, that gives me 2 to the negative 2nd power. X raised to the 3 times negative 2 power would be x to the negative 6 power. Y raised to the negative 3 times negative 2nd power. Negative 3 times negative 2, well, that's positive 6. So now you can see the term that would have been moved down in the basement would have been the y to the negative 3. And I would have been bringing it back up stairs after multiplying to that negative power outside the parentheses. So we're going to look through our solution. I have 2 to the negative 2nd power. That's got to move to make the power positive. I have x to the negative 6th power. That's got to move to make the power positive. So we come to our final stage. My 2 to the negative 2nd power will become 2 squared, which I know is 4. My x to the negative 6th power will become x to the 6th power. And my y, since it's already got a positive power, will stay in the numerator. So we end up with y to the 6th power over 4x to the 6th power. $37. Actually, I just did an odd, so let's do 38. We'll call it an evening. Negative 2. A to the 3rd, B to the 2nd, C to the 0th power, over 3A to the 2nd, B to the 3rd, C to the 7th power, all raised to the negative 2nd power. Now again, there are multiple ways that you can attack a problem like this. Do remember that anytime you have a negative power, like the one we have outside the parentheses, it's going to change every power inside the parentheses to its opposite. So if I were to think through this, negative 2, which has a power of 1, raised to the negative 2nd power would become negative 2 raised to the 1 times negative 2nd power. Well, if it has a negative 2nd power, it's going to cause it to come down below my fraction bar. Let's look at what happens to the a. A to raise to the 3 times negative 2. Well, 3 times negative 2 is negative 6. That's going to bring it from the numerator down into the denominator. So we can see that because this is a negative power outside, it's going to cause everything that's in my numerator to drop to the denominator, and everything that's in my denominator to come up to the numerator. So I'm going to do that all in one step. Negative 2 raised to the first to the negative second power is the same as negative 2 raised to the second power just in the denominator. A to the 3 times negative 2 would be a to the negative 6, so it's going to come down below the bar and become a to the positive 6. B to the 2 times negative 2, so 2 times negative 2 is negative 4, will become b to the negative 4th power, so it also will come down into the denominator and become b to the 4th power. C to the 0th power, I can go ahead and write as 1. And 1 times 1 times 1, doesn't matter how many times I multiply it by itself, it's still going to be 1. So really that C is going to go ahead and cancel out. I don't have to worry about it at all. Now let's clean up our denominator. 3 raised to the power of 1 raised to the power of negative 2 becomes 3 to the negative second power. So it's going to come up into the numerator, 3 to the second power. A raised to the second power raised to the negative second will be a raised to the 2 times negative 2, which is negative 4. So it's also going to come up into the numerator, a to the 4th power. B raised to the 3rd power raised to the negative second power. So 3 times negative 2 is negative 6, so it's also going to come up into the numerator. C to the 7th power times negative 2. 7 times negative 2 is negative 14, so this value is also going to come up into the numerator. Now we can start to clean some of this up. I can see right away that 3 squared is going to equal 9. Negative 2 squared will be negative 2 times 2. Sorry, negative 2 times negative 2, which gives me 4. And I'm going to clean a couple of these other ones up off to the side, just so I can show you what's taking place. A to the 4th power over a to the 6th power. We can apply our quotient rule because we have the same base and both of them have powers. A to the 4 minus 6th power would be a to the negative 2nd power. And since it's a to the negative 2nd power, I know I'm going to bring it back down to the denominator, so that becomes a to the 2nd power. And another way of remembering that is, remember, a to the 4th power is a times a times a times a. That would be 4 a's. A to the 6th power would be 6 a's. So 4 of my a's from the numerator will be canceled out by 4 of my a's from the denominator and leave me with 2 a's in the denominator. And that's what a to the 2nd power means. Now we'll do the same thing with our b to the 6th power over b to the 4th power. We'll use our quotient rule, which tells us we keep the base and we subtract the powers. B to the 6 minus 4, well, 6 minus 4 is 2. Now we go to our last term, the c. There are no c's in the denominator, so there's nothing to cancel out any c's. We're simply left with c to the 14th power. So we end up with 9b squared, c to the 14th power, over 4a squared. Hopefully this served as a good reminder of how to solve several of these types of problems.